going to do is deploy Hadoop and run a Hadoop job in just under 10 minutes. Now, I've already bootstrapped Juju into our cloud so we can just get going right away. First step we need to do is deploy Hadoop's name node. The name node service sits at the front of the cluster and coordinates all the activities of the other bits. Now, we use a charm, which is a collection of scripts and description of how the service works that a Hadoop expert has already prepared for us. We've got a prepared configuration that sets some tuning values. After that, we need the data cluster. That's the scale-out portion of Hadoop that processes all the smaller bits. And we'll go ahead and just deploy one of them. And if you look in the top right, you'll see the visualization of the Juju tree start to expand. That's going to represent the data structures and different services that we've defined already in Zookeeper. And you'll see it moving even when we're not typing commands, because things are happening in the background. Now, we also want to keep an eye on all this service, so we'll deploy Ganglia. Ganglia is a cluster management tool that monitors things like load and memory, and we'll deploy a single service of that, and then next step, we'll go ahead and relate it to our services. First, we need to relate the name node to the data cluster. Juju has the concept of relations, which are two-way channels of configuration data that trigger scripts to make things happen. First, we did the name node to data cluster. Next, we're going to do the job monitor to the data cluster. Now, that's going to inform Ganglia of all the nodes in the data cluster, just like it informed the name node of all the nodes in the data cluster. All this is going to happen in the background and asynchronously. Now, so that we can look at our Ganglia instance over the web, we need to expose it. By default, all the services you deploy with Juju are hidden. So this just opens up the firewall port in the way that the charm author has specified. Now, Hadoop wouldn't be anything if we didn't scale it past 2 nodes. So we'll go ahead and add 6 more data cluster nodes before we start our job. This is going to tell Juju that it needs to expand our cloud, and that's all going to happen asynchronously, independent of one each other. So all these nodes will be started and doing their own thing, nothing waiting for anything that it doesn't have to. Eventually, they'll come online and check in with Zookeeper, and you'll see them up in the visualization as they start to come online. And if we want to keep an eye on that process, our course visualization is good for a high-level view, but you can also run Juju status, which will output a YAML that shows a representation of everything inside Zookeeper and the state of all the services as they're coming up. So here we say that a lot of things are pending. They'll be up soon, though. All right, so we've given our nodes a little time to spin up. Now we'll go ahead and SSH to the name node, and we'll give it some work to do. Now, the author of this charm included with it a little test script to generate what's called a pterasort. This is a good way to put a Hadoop cluster through its paces and give it some work to do. It's a nice way to check out that you haven't done anything wrong. The cluster is somewhere in user lib, so we'll just start it up. First, it has to generate a bunch of data, so it's going to take a few minutes. But once it does, it'll sort it, and it'll go faster and faster as nodes come into the cluster. Not all the nodes that we started earlier have come up, and you'll see in the visualization that they continue to come up and change their status. All right, so now we've got some data pumping through. It's not easy to see, but it actually gets faster and faster every time a node comes up online. One of the things that's even more interesting is to go ahead and watch and see what the nodes are doing. That's why we have Ganglia. So you can see a few more nodes coming online, changing their status. And Hadoop slowly getting through its data. We'll go ahead and check on Ganglia, which I've already saved the address to up here. It shows 2 CPUs now, but that's because there's a little bit of a lag as they come online, and they need to record some actual metrics. So now our load graphs are actually showing some work, and a few more CPUs have registered in with Ganglia, and our job is actually finished because we got so many nodes involved. So if we look around, we've deployed about 9 servers, all coordinating to get a Hadoop job. It wouldn't be much longer if we had done 90 servers, though it would have been a little more expensive. So that's about it. We put together a Hadoop cluster, run some data through it, just under 10 minutes in a completely automated fashion. And one of the best things about automation is when you're done, you can go ahead and just tear it all down. So that's what we'll do with one command, Juju destroy environment. And this is going to systematically tear down all the pieces until there's nothing left and all our resources are reclaimed. And if we're in a public cloud, we're not paying for any more of those resources.
So that's how you deploy Hadoop with Juju. If you're interested in deploying more things, come to ubuntu.com/cloud.